So number 23, we're talking about the equation 8 over x and x squared. So that would be, this is our x squared, and this is 8 over x. And then it goes from 1 to 4, so I just cut it off. This is x equals 1. This would be the vertical line, x equals 4. And then y equals 0 would be the x-axis. So this is the area that I'm looking for in here. I'm going to write the equations that go with these. So again, this is number 23. The top this equation here is which one? Y equals x squared, right? And this equation is 8 over x. And then this equation is obviously 0 down here, and this is the area I'm looking for. So if I'm looking for that area, is there one equation that's on top and one equation that's on bottom? Am I finding the area between curves here? No, I'm finding an area that goes down to the x-axis. So I'm not really doing the subtracting thing. But don't I have to split this into two separate pieces to get the area? Because do you see how from here to here, if I found the area under this curve, wouldn't I get this shaded piece? And then from here to here, if I put this equation in there, wouldn't I get this shaded piece? So that's what I have to do for 23. So where do those intersect each other? What value is this here? 1. This value is 2, and this value is 4. So I'm going to go from 1 to 2. And what equation goes in there? My x squared, right? And then I'm going to add that to the area from 2 to 4, and in there I put 8 over x, which is the natural log of the absolute value. Okay, the 8 can just be pulled out front. So from there, are we okay taking antiderivative and plugging the values in? I think the setup is what gets us for the most part. So that takes care of 23 there. So number 27 we're going to look at. We're given f of y, which just seems a little weird, equals y squared, and g of y is equal to y plus 2. So any ideas on how to do this? Could I just switch them to x's and do it that way? Okay, is the graph important here? Sketch a region bounded by the graphs of the functions and find the area of the region. See, I guess our graph we need to have here. So this is like an x equals y squared, right? And this is like x equals y plus 2. So could I solve this for y equals? Okay, if I solve this for y equals, how do I get y by itself? Square root. And what do I have to do when I square it? Plus or minus. So if I'm going to put this in my calculator, my y1 would be positive square root of x, and my y2 would be negative the square root of x, because you can't really do a plus or minus in your calculator. Otherwise, you're only going to get the top half, but you need the bottom half. So this is a parabola that opens to the right. And how do I solve this for y equals? X minus 2, right? And so this would be my y3. Can we use that then? Let's put it in our calculator and see what happens. So L square root of x. So we got positive square root of x, and we're going to do negative square root of x. I'm just going to clear it and try again. There we go. Negative square root of x. And then the other one was x minus 2. Is that right? And we might have to switch our window a little bit. I think the area would come out the same, did it? Yeah. It depends. If it asks for the graph, your graph should be accurate, you know? As long as you get the right area at the end, yep. Okay, so let's try to find a good window. Does anyone have a good window? Otherwise, I'd probably just try negative 5 to 5 for all of them and see what happens. So this is what the graph is looking like here. Takes a little bit sometimes. Okay, so this is the parabola that opens to the right, and then this is line SAR, and I'm trying to find this area here. So if we're going to do this with respect to x, and I think it's important to go over it, let me go like 0 up here for my x's. And then the y's maybe -2 to 2, just to zoom in a little bit. I think it'll be easier for you guys to see this then. Because I think it's important for us to be able to just look at a graph and be able to come up with it, what our answer should be here. And this one kind of is confusing if you don't know what you're doing here. So if you're tuned out, tune back in here because I want to talk about how to find this here. Okay, everyone ready for 27? To understand how to do this with respect to the way the problem actually is. All right, if I'm trying to find this area in here, I can do the top curve and subtract the bottom curve, right? And if I'm going from 0 to 1, just from here to here, isn't the top curve this square root of x? And what's the bottom curve? Negative square root of x. So if I went from 0 to 1, I would do the top curve and subtract the bottom curve, which gives me what? What's square root of x plus square root of x? 2 square root of x, right? So that's what I'm going to do from 0 to 1. And the 2 you could pull out front, right? So from there, we should be able to do that. But then do you see how from 1 out to, is it 4 here it looks like? From 1 to 4, what's the top equation? Square root of x. And what's the bottom equation? X minus 2. So if we're going from 1 to 4, I would have the blue on top, which is square root of x. And the line is on the bottom. So if you take the top and you subtract the bottom, that should give you this area here. So the line would be x minus 2. Does everyone see how that works? And then from there, taking the integrals, I'm not worried about. If we don't know how to do that, we need to get some extra help here because we've been doing that for a while. But the setup here is what's new. You do the antiderivative of, yep, you'd solve this here by doing antiderivative and plugging in the top and subtract, plug in the bottom. And then do the same thing here, antiderivative, plug in the top minus plug in the bottom. And then what do I do with these two integral answers? Add them together, right? Because the one gives me this area and the other gives me this area. Should I ever have a negative for these area pieces? Not if we did them right. Okay, so that finishes up 27 there for you. So you guys can finish that up. For number 21, I just threw those equations into my y equals. And I'm just going for my window from 0 to 1. So 0 cuts it off, which it's actually pinched at 0. And then 1 is like another line here. Okay, so the area that I'm looking for, whoops. Let's try that again. The area I'm looking for is the area that goes from here out to 1. So it would be like this shaded piece. So I'm just going to go from 0 to 1, right? What's the top equation? Okay, and then my bottom equation is just 0, right? So do I really need a minus 0? Not really, right? So this is my equation. Now, some people might have difficulty taking the antiderivative of that. How do we take the antiderivative of something like that? U substitution, what's your u going to be? Negative x squared. So then your du would be the derivative of that, which would be negative 2x to the first dx, right? So then dx is going to be du over negative 2x. And if you're switching to u's, don't put the 0 to 1 on there because you need to plug the x's back in before you do the 0 to 1. So my integral, instead of x e to that power, it's going to be x e to the u. And instead of dx, I put du over negative 2x. So do you see how the x's cancel each other? What constant can I pull out front? Negative a half. And in the integral, then I just have e to the u du. What's the antiderivative of e to the u? E to the u. So I have negative a half e to the u. Plus c, but I don't need the plus c because this is a definite when I'm done here. And instead of u, I'm putting what in there? Negative x squared. And I'm going to take this from 0 to 1 now. So go ahead and try to finish that one now. All right, so 52 factory orders for an air conditioner are about 6,000. So we have 6,000 as the number if the price is what? Who needs 52? 331. And 8,000 if the price is 303. Okay, now we have to figure out which ones are x and which ones are y before we do a linear equation. So let's keep reading. It says the supply function is given by p equals 0.0275x. So do you think x stands for the amount of money or for the number if we're talking about supply? The number, right? So this is our x and this is our y. So can we come up with our demand function then? Can't you just use your calculator, do your L1, L2, right? So if you have your supply and demand, then can't you just do the equation or do the problem just like we did in the notes? Is that what we were having trouble with, was getting started? It should just be a linear, yep. Supply and demand are just linear functions. Where they meet, remember, that's the value that you're using for your consumer and producer surpluses. To find the area of the top is the consumer and the area of the bottom is the producer. So refer to your notes to get that one finished up, okay? But do a linear function with these, that's going to be your demand function.